Hello, good evening to all of you. Here we are in the third session of module 3, and till now we have discussed about different types of signal operations, just simple operations, basic operations. We will continue with some new techniques, new things in today's session. In a few minutes, Dr. Atul Kumar Dwivedi sir will join and we will continue. Hello. Dr. Atul Kumar Dwivedi sir has joined. Welcome, sir. Good evening to you. And there are some about 10-11 participants. We can wait, sir. Okay. In last session, we have covered how to read data from Excel sheet, how to read data from text file, and vice versa, how to write them. So if we have any queries regarding those, we can discuss about those for a few minutes. Then we will continue with Dr. Dwivedi sir on the new topic. And we will share the handout and as well as the practice sheet. We had shared the handout, but by today we will share the practice sheet based on the lecture number 2 as well as today's lecture. Hello, Atul sir.
Oh, yes,
Can we start, sir? There are only 14-15 participants.
yes, that's what I was seeing and waiting for others to join. If you say, I will start.
Okay, sir. So, dear participants, if you have any queries, any confusion regarding last session, the recording also will going to be shared by between the lecture duration. So don't worry about that. And if you have any queries, any confusion, we can discuss for next 2-3 minutes. More participants are joining now, and then we will start with a new topic.
Okay, I think now we should start
Yes, sir,
because
we can start.
other participants will join in between, and I will see that. Okay, so because of that only, because we are going to discuss something new, so therefore it was better if they have joined from starting. Otherwise, it may be problem. Okay, so once okay. Okay, no issues. Let us start discussing. The Today we are going to discuss about two-dimensional signals. Two-dimensional signals are images, vibrations, kind of thing, geographical signals like that, analysis type of signals. So today I will discuss images basically. What I thought that first of all, let us cover the how to represent the signals, how to bring them in MATLAB, how to do analysis of the signals. Then we'll go for the filtering and feature extraction from the signals. That is why today we decided to discuss image processing, or how to deal with images in MATLAB, how to take them to MATLAB, how to do some analysis on MATLAB, and then we can save it to MATLAB like that one. So I will share my screen. Okay. Yes. Is this visible now? Okay. That
Yes,
we
sir,
had
it's
to discuss. Yeah, it is visible. Okay.
yes,
Now
sir.
I can see this is visible, and two-dimensional signals, that images we are going to discuss, and the content of today's discussion will be that what is human interpretation, machine perception, what are the applications of image processing, images at matrix as image, and image cropping, image rotation, resizing, image bitplanes, watermarking, etc. So we all, I'm just going now in the full screen. So you'll see that we all are the visual creatures. Humans are visual creatures. They perceive things by visuals. We can identify faces in an instance, and we can differentiate colors, and we can process large amount of data in just instance. Our brains are so much powerful, and we like the images which are beautiful. So the images which are beautiful, we like that. Okay, so I will say that the pictures which like this, which are beautiful, they human beings like that kind of things. So machine considers differently. For machine, the data which is having less amount of data to process, that images which have less data, that are better for machines. But images that have more data or more pixels and better resolution, they are good for the human beings. So these two are different aspects. For machine and for the human being, things are different. Image processing, can all applications, all parts of image processing can be divided into two things. First thing is human interpretation, how human mind interprets the thing, and second thing is machine perception, how machine thinks about the image that we have loaded into. Okay, so this human interpretation and machine perception I will go through. First image is left side image is better or right side image is better? You will say that both look
Right side, sir.
similar, but actually right, yes, the right side image is better. Yeah. Why it is better? Because here the more information you can see compared to the left side image, because this is more sharp compared to the left side image. Okay, here left side image is good or right side image is good? Yes, Raj Tiwari sir, and Padmalata madam is also saying right. Yeah. So everyone will say that right side image is better because left side image is completely black and white and no information is there. But in right side image, we can see that in background there is some tiles kind of thing and is there, and even we can see that pen is in the pocket. So these things are not clear in left side image. So yes, so this is right side image is more better, much better than the left side image. Here, although I have not taken good quality color image, but the color image is better compared to the grayscale. That in the color image we can see the colors also. So again, which one is better, left or right? Again, right side image is better. Yes, Kapil, because it have more information than the left side image. Again, here's what is happening. I'm actually discussing human interpretation. What we see in the image, what we actually see the image is how we perceive them, how we interpret the images. That's matter. So here, left side image is noisy image. Of course, everyone will say that this is not good, and right side image is better than left, because in the right side image, noise is not there. So by image processing, you can improve human interpretation just by removing the noise. So you can remove this kind of noise by the help of image processing, doing some processing in the MATLAB. Okay, you can see here because of camera motion or motion of the object, left side image is blurred. So by doing some filtering or doing some processing, image processing, you can improve the quality of image. So again, every time you will say right, because right is better than left. See here, left side is, now I will ask, left side image is better or right side image is better? Now you tell. Left was see now our conclusion for the some are saying, some of us that like are saying left and some of us are saying right. So the confusion is there because of the problem, that the lighting problem in this image. In the left side image, the lighting is not proper. For in the all complete image, proper brightness is not there. So but the right side image contrast is there. Although it is black and white image, although it have 0 and 1s, means it have only black and white two colors, but contrast, that contrast and uniform background, that is saying that right side image is better. For machine also, the right side image is better. Why? Because here machine have to process only two data. Not the lot of data is there in the left side image, but in the right side image data will be less. I will tell you how data is less. Okay, now see here, which one is better, left or right? Left or right? For us, yes, I can see that most of the people are saying that left is better. Yes. Okay, so you can why left is better? Because here the sampling rate, the sampling is proper. But in right side image, the sampling is not proper as per requirement of the size of the image. The sampling is not proper. Therefore, left side image is better because that is having correct sampling. Right side is not having correct sampling. But for machine purpose, machine perception, because we are discussing the machine perception. So, for if I ask for the machine perception, then your answer will be right side image. Why? Because machine will have to process less data if the data is under sampled. Less number of samples will be there in the machine. Therefore, there will be the less. Right side
Sir, audio is not coming properly.
images better for.
Sir, audio is breaking.
Sir, your voice is not clear. Hello.
Hello, sir. Okay, actually, there might be some network problem. Let me check. Sir, am I audible?
Okay. Sorry, there was some.
Yes, sir. It's audible.
There was some network issue, so therefore that break in between.
Okay, sir.
Now it will be okay. Good. So what I was saying that this right side image is better for machine purpose, and left side image is looking as for our human is saying that left side image is good, but machine is saying that right side image is good. Why machine is saying that right side image is good? Because here less number of samples will be there. So this less samples, less data to process. If in the less data, machine can make same conclusion. That conclusion it will make from the more data. Then machine will prefer to have less data. Okay. Now let us discuss some applications of image processing. You can also tell that first segment of application I will select medicine. In medicine, how image processing is useful. In medicine, a lot of images are used nowadays. One example is MRI. The process of taking images can be different. The process of yes, Padmalata madam, you are correct. MRI is one example. CT scan, that is also an image. Any other? X-ray image we also actually the process is different, but we get the image in final output. Ultrasound is also comes in the form of image only. Okay, so ultrasound. Now, ECG images. Okay, if you say in the form, if you take as an image, that can also be used. ECG generally is a time domain based data, but in the form of image it will also. Yes, there are a lot of signals that comes in the form of images and extension of images video. So in many operations or many surgical things, they use microscopic surgery nowadays. So microscopic surgeries that all are done with the help of videos. So videos are also a extended part of image only, extended images only, with one more extra dimension. Okay, so in this way, medical field is very much dependent on the image processing. Okay, next is this agriculture field. So agriculture, how image processing is useful. You can do, actually they get prediction of rainfall by using weather forecasting. Weather forecasting also depends on the satellite images. So they are taking images for that purpose. So you can say weather forecasting is useful for the agriculture. So weather reports. And second thing is crop yield. Crop yield can also be estimated with the help of images. And the third application that is given by Anirudh Kumar, plant diseases. So by plant disease detection, this is a very known project that many people do, that finding out different kind of plant diseases by taking the images of the crop, means leaves of the plants. So plant disease detection is one application. So there are many applications of in the agriculture field. Okay, industries. There are many applications in industries. How industry use image processing? They use CCTV cameras for their protection, for security purpose. That is okay. But for agriculture, for industrial products, are there any application? Automatic counting. There are systems for automatic counting based on the images. Means there will be a camera continuously capturing the frames, image frames, and if the particular object is detected, it will increase the count. If further object is detected, it will increase the count. So they use automatic counting system, authentication of their products, also done with the help of image processing. Law enforcement means at certain places they have put CCTV cameras, or for the purpose of anyone who breaks the red light at the crossings. So then they will capture the image of number plate. So that number plate image will help to enforce the laws. So number plate detection kind of things are law enforcement in the society. Okay, so and security again, you can have fingerprint sensor for fingerprint images. So that is fingerprint security. So fingerprints are used for security purpose. Iris images means and face detection. These all are used for the security applications. So images are yes, correct. So face recognition systems, these all are used. So there are applications of image processing in the security purpose. In defense, how images are useful? Yes. Yes, Uncle. Drones. Yeah, drones. Drones are there in the defense. Yeah, radars, night vision camera. They have night vision cameras. Thermal images kind of things are there for images. They use the thermal vision kind of applications. Any other? You just write in the chat window. I will see. Yeah, very nice. And they have the CCTV again. CCTV almost in every application, everywhere, in every office, every places they are putting nowadays cameras. That cameras are used for analysis, for security analysis, for many kind of analysis they can do with the help of this CCTV camera. So that is really helpful for the defense also. And this environmental studies, like I was telling, that weather forecasting and many other applications are there that all cannot be listed also. That I cannot list all applications of environmental study of all applications. Any other application if you think of, you can tell. Overall, the idea is that the image processing or images are in almost all areas of life. They are coming into. So, okay. So the process of yes. The question, there is one question I can see that that UP Verma. How and what mechanism works behind image processing in automatic manner? There are many mechanisms, many algorithms behind automation. I will just you can see this block diagram. It will tell how image processing actually works. So I am just explaining the same answer of the same question, that what mechanism work in the image processing. Here you can see, this is the problem domain. On here we have the problem, whatever wherever image processing being done. So images are here. There will be the sensors for images, camera, maybe scanner, or maybe there are many other ways also generating the images. So image acquisition will be there, and after acquisition of image, this will be added to the database, and the database it will be saved. Now from the database, other algorithm, other process will take it and do the enhancement, do the quality improvement, will remove the noise, will remove the non-linearity, some whatever basic problems. This is called actually a pre-processing kind of thing. And if there is the image is corrupted, it will try to restore its original quality, matching with the image quality of the other images. So this process will be image restoration process, image enhancement process. These are the pre-processing of the image. So pre-processing will be done. After pre-processing, they will do some feature extraction like wavelets, some compression if required. If the data is too much, then compression will be done, and the some morphological process to detect the objects in the image, to do find out some special things in the image. Actually, this is an image analysis kind of thing. So here we are doing the pre-processing, and then here we are doing the feature extraction, analysis and feature extraction. Again, this part is mainly analysis. These four: segmentation, representation and description of the images, and object recognition. So object recognition is done by doing some analysis, there are some special algorithms for doing the object detection. So especially morphological process, it works for the image image object detection. We'll discuss it later. Okay, so these are the fundamental steps in image processing. See this image. This is one image. Whenever we plot something, we usually write X here and Y here. But in this image, what I have written, X here, this is going down, and Y here. What is the reason of this? The reason is that when we take image into the MATLAB, then it takes it as a matrix, because in MATLAB everything, most of the things are matrix. Okay, so the matrix will be like this, will be matrix of pixels. There are thousand lakhs of pixels in this image. There are every point wherever I can put my cursor, all are pixels. So this numbering will start from this corner. Numbering will start from left side, upper corner. Okay, numbering will be 1, 2, 3, 4 like this, because in MATLAB the indexing starts from 1. Here also numbering will be 1, 2, 3, 4 like that, because in MATLAB numbering starts from 1. And in matrix, everyone knows, if you have a matrix, suppose we have a matrix of 3 cross 3 which have numbers 1, 2, 3, 4, 5, 6 and 7, 8, 9. Suppose this is the matrix, then first row and first column of this matrix will be 1. Suppose M is the matrix, then first row and first column of this matrix will be equal to 1. So here then if I represent this X and this Y, then this will be a starting of XY. And second row M, this is actually second column, first row and second column. What increased? Y. Y is increasing. Here this last 3 will be equal to M 1, 3. First row, third column. What is increasing? Y is increasing. Here if I go downwards, then this will be second row, first column. This element will be this 4 will be represented by second row, first column, isn't it? And this will be 7 will be represented by third row, first column. So what is increasing? X was 1 here, now X is 2 here, now X is 3 here. X is increasing. Understood why I took X here and Y here? Okay, I think you got the point. Reason why the image works like that. If I plot every pixel value of this image, if I plot every point of this matrix, then that is represented as a stem type of plot, stem kind of plot. So this is a 3-dimensional plot. Here I have plotted. Okay, so in 3D plot, if you see, then every pixel will have some value. Some have less value, some have large value, some have some kind of thing like that. So this way the image will look like. Actually, the inside of image, the intensity of the pixels will be like that. See here, the maximum value will not go beyond 250. In RGB kind of image, if this is a red, green, blue type of color image, then maximum value will not increase more than will not be more than 250. Great. Okay. So you will say that, sir, you are telling, so you are doing telling and discussing a lot, but it will be better if you show in MATLAB. Yes, that's what we want. We are here to learn MATLAB, not just theory lecture. So I will go to MATLAB now. Yes. Till now, if anyone have question, then why it cannot be more than 250? Yes, I can see Raj Tiwari. I've asked the question why it cannot be more than 250. Yeah, I said sorry. It will be 255. It can be more than 250. It will be up to 255 because the range of these values are 0 to 255. Usually, the camera or sensors of images are of uint unsigned integer 8-bit type. So the range is from 2 to the power 0 to 2 to the power 8 minus 1, like that. Therefore, this is 0 to 255. Actually, this is not this is 250 for this particular image, but maximum possible is 255. That is what the reason is for that. So if camera is different, this is for general most of the cameras. If camera is different, it may be different. And also the encoding, RGB encoding, if we are using the RGB kind of encoding, then even if your camera is better, it is having higher values of bits, then if you are saving it in the RGB coding, it will be converted to 0 to 255 because of this encoding. Okay, let's go to MATLAB now. Okay, this is MATLAB. We are here, so I will change my folder. I'm changing this so that we in image processing folder, and you can just change your directory to the place where some images should be there. Then it will be easier to do the work, because we are dealing
So
with
there is a question.
yes.
There is a question by Mr. Umesh Verma. How we get values of Z in previous one?
Yeah, how to get value? How we get value of Z? I will tell you. It will come. Just as you understand that how images are processed in MATLAB, how we deal with images in MATLAB, then you will get value of how Z. Actually, here x and y are dependent variables. Let us go to that. Let me tell now itself. Okay, so here you see when you supply the value of x and y, that I want that 50th row and 50th column, for example. If you want the value of 50th row and 50th column from the matrix, then whatever value comes, for example, if that value is 100, that value is Z value. Are you able to get, sir? Ms. Verma, sir? When you supply row number and column number to the image, then whatever result comes, whatever the value, suppose I supply this 3 and 1, then 7 is coming. This 7 is actually Z value. So the value of particular pixel is Z value. The location of that pixel is value of X and value of Y. The location will be calculated by row number and column number. So location is calculated by X and Y, and Z here in this plot, Z is coming for the particular value of that matrix. Okay, let's come to MATLAB. This is MATLAB, and here Okay, so we can see here the complete. I will just keep pen with me so that. Okay, so now we are in MATLAB. I can see that I put some. I put some images should be there in your current directory, but here I can see that this is blank in my system also. So I'll go somewhere. I'll change this. What is happening? Okay, so you can see that CLC clear. Okay, so I have just I will change this work here. I hope that I want images not to be, images can be anywhere. This is not necessarily to be in the current folder. You can, but if the images are not in current folder, then you have to give path. Complete path I have to write. So I don't want to write complete path always. I just want to use images directly. Okay, so that's why I am going to the folder where I have images. So I just went to this folder, work folder, my image processing course that I have, and in the work folder I have many images like this atul.jpg, atul-new.jpg, baboon.bmp, bacteria.tif, like that. There are many images. So images can be JPG, BMP, PNG, TIF. Many image formats are available. GIF. So these kind of images can be there. So any image, whatever you have, you can just go to the folder wherever you have the image. So how to get it into the MATLAB? You just have to write command. For example, I equal to imread. Suppose I am taking this new one, my new image, atul new dot jpg. Simple commands are simple. What it will do, it will take the image into MATLAB and it will convert image into matrix, because images are not a vector like the signals we were discussing till now. Our signals were simple vectors only, which have one-dimensional data, but images have two-dimensional data. So we will get it into a matrix form. Already I have told you. No issues. So now I will just press enter. When you press enter, it will read it, and it is saved into the variable A. You can see. If I do not keep this semicolon, it will read it and it will show the values in your command window. You can see the values. If this image is different image, for example, if I take the parrot image, if parrot image is there, that image is a little larger, then it will take more time to okay, so parrot.jpg, this is there. So if you have a larger image in your system, it will take a larger time to come into the MATLAB. See, this image was larger compared to the previous one, therefore it is taking a longer time compared to the previous one. So one thing is that you just keep the semicolon suppression operator. When you keep the suppression operator on, this suppression operator, the semicolon will make your it is importing faster. So you should generally use semicolon after this command imread. So when you write imread, you just write A equal to imread whatever atul dot jpg. If you have PNG, then you have to write PNG and then semicolon. This semicolon will make faster because MATLAB don't have to display. This display also takes some time. Okay, no issue. So image is now here, and we can how can we see this? This is actually a matrix now, and why this 3 is written I will tell you later on. And before that, I will like to show you the image. Just I will show you the, otherwise you will say I don't know whether this image is there or not. So for that, for seeing the image, command is IAMShow, then the variable name in which we have stored the image. IAMShow, and then the variable name in which we have stored the image. Okay, so variable name was, you can see, I had written a equal to IAMRead, whatever image was there. Which was this? This was actually parrot.jpg. I had written this. So because of that, what happened in my workspace, variable A is there. This is actually a matrix, and just I want to show it into the MATLAB, then I have to write the name of variable A. IAMShow. Good. Press enter and see the result. See the result. I hope parrot image is visible to everyone. So I can see this is a figure window of MATLAB only. This is not a figure window of any this other software. This is of MATLAB. Here we can see. I will again will say that what's the big deal that we can see images in any other software also, but here we will do image processing. We will do some processing later on. We will do image filtering also later on, and we can create our own filter that is not available in the predefined softwares. Image processing software, image editing software, where they will not have your customization or customized algorithms that you will like to write. Okay. So anyway, there are some tools, but before going down to that, some tools in great details of image processing. The question I will like to ask with you, that you will say that, sir, okay, the image is a matrix, and by using this IAMRead and IAMShow command, IAMRead is working for reading the photo or any image. IAMShow is showing you the image. Then the next question is, will matrix will also be converted to image? Similar to the last time that this Ms. Verma sir had asked that, sir, can we save any data to audio file? Similar question this time also anyone can ask me that, sir, can we save any matrix to image? Because images are coming into MATLAB and it is getting converted to matrix. So can any matrix be converted to the image? That is also answer is yes. We can convert any matrix into image. And what is matrix? How to deal in MATLAB? Those who have gone through our previous modules, like module 1, fundamentals of MATLAB, they must be knowing that what is matrix, how to access any value of the matrix, how to create a matrix, how to save the matrix, how can we change the matrix, how to check transpose of the matrix. There are many things in matrix. So just I will give you just a brief idea here that what is matrix. So actually just I will clear all those things, the previous things. Matrix in MATLAB, actually everything in MATLAB is matrix. That is why its name is MATLAB, Matrix Laboratory. Even if you create A equal to 1, this is a single value variable, but for MATLAB, this is actually a matrix of size 1 cross 1. If you ask from MATLAB, what is the size of A? If you ask from MATLAB, what is the size of A? It will not answer 1. It will answer 1 cross 1. So even a single variable is also a matrix in MATLAB. If I create a vector equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have created a vector of 10 values, A is having 10 values starting from 1 to 10. Again, if I ask from MATLAB that what is the size of A, now size of A, then what will be the answer of MATLAB? MATLAB will say, sir, this is having this data that you have created. This data is having 1 row and 10 columns. This is also matrix, but this is a row matrix which have 10 values, single row but 10 values. So that is also a matrix. Even if it is in the form of column having 1 to 10, if you take transpose of this, then also that is a matrix. Anyway, that is not a discussion point of discussion. What discussion is, if I want to create a matrix like this, what should I write? Just simple. If I want to store these values into A, then what should I write? Anyone can answer, because there are people who know. So I am just telling for those who are new, who have directly joined to this module. So they might not be knowing that how to store this. So just I am telling this thing for them only, because I know that there are some participants who have gone through our previous modules. They already are experts of these things, and they don't need knowledge of this thing, that how can we store, how can we write in MATLAB this. Yes. So okay, so what I have written 1 space 2. We have to start with the square bracket. Then first row is 1, 2, 3. So 1 space 2, then space 3. Space is mandatory. Do not forget to put a space, and then semicolon. Semicolon, what semicolon will do? It will change the row. Currently, we are going in the first row. Semicolon will change to the second row, and then semicolon will change it to the third row. Okay. So in that way, when I press enter, you can see that A is having now matrix. In A, the matrix that which I wanted is now saved. So if I want to access 5, if I want to save this 5 value from this matrix, this 5 value only from this matrix, what should I do? What should I write? B equal to A. Just you have to give row number and column number.
2.
2, 2. It will work. It will work. So if I write like that, and then that will be A 2, 2 equal to 5. You can see B equal to 5. So in that way we can access. No issue. You also know that if I want to save these 4 values 5, 6 and 8, 9, if I want to access these 4 values, means 5, 6 and 8, 9 into a variable C, then what should I write? Ultimately I want to create a submatrix of a big matrix. So I can create it separately. means by writing a separate code for that. But what I want, I just want to separate a part of matrix. What should I write? C equal to, yes, A. See, here you had given row number first. So I will give row number first. What are the row numbers? 2 and 3. These two are rows. And what are the column numbers? 2 and 3. These are the column numbers. This thing you have to write. It will save this submatrix into the variable C. Let us do it. I will also do it and see whether this is working. This is my code. Whatever I have written here is working or not. Because C equal to, yes, this is right. This code is right. And we can, so think about the image. Image was a matrix, big matrix, having many hundreds of values. Complete image was having hundreds of values. So if you want to separate a certain part from the image, you want to crop certain part of the image, you don't have to go into the crop editor. You just have to write a command like this. Command like this will do the thing. You have to go give the, see here, you will say that how many rows we will write. See, you know the colon operator. That starting row number and last row number you have to give only. You can put colon between. In between you can put the colon. Colon operator what will do? It will start from the starting number, it will end up to the ending number. So in that way you can separate any part of the image. Just you have to give the starting row number, starting end row number, starting column number, end column number. So any part of the image can be separated. That is what is beauty here. That by knowing the matrix, you can do the image process. Okay, so why I came here? I came here to convert a matrix into image. Now we know how to create a matrix. So I will create a big matrix. Okay. How much big? How can I create a big matrix? I want to have 100 rows and 100 columns. In my variable A, there should be 100 rows and 100 columns. How can I generate? A equal to row number, rows value equal to values should be 1 to 100 numbers. Okay. Column. Second row again 1 to 100 number. Third row. So I have to write rows again and again by writing semicolons. Okay, so there are some predefined commands. So let us use that. You can use once and 100 rows and 100 columns. Why don't we do this? Once 100 rows and 100 column, this command will do that. It will create a matrix of 100 rows and 100 columns, all values 1. So I will do the multiplication to this. Multiplication of anything, a multiplication of 100 suppose. So now the value, this will create a matrix of 100, value of 100, 100 cross 100. Okay, so see here, this is 100 cross 100 matrix which have all values as 100. I will write IMShow command. Let us see what I have never seen what it shows. But suppose this matrix is there. Why I have taken a big matrix? So that at least 100 by 100 it will be we will be able to see, because very less 3 cross 3 matrix it will be very small. I will show that also and how that looks. See here, this is a white image. which is having white values of or this is a 100 cross 100. This is the size of 100 pixel cross 100 pixel. Oh, see, this much small is 100 by 100. Then how much small will be 3 by 3? So just there is one matrix called magic matrix. Those who have gone through this matrix, they will all know. I have written magic 3. What is the magic here? I have written magic 3. What is the magic here in this matrix? So it have created one matrix of A, which is having 3 rows and 3 columns. Some random numbers are coming, 8, 1, 6 and 3, 5, 7 like that. But what is the magic?
Sir, sum of each row and each column is 15.
Yes, that is the magic. That here is the sum of row and column and diagonals.
Diagonal also.
So that is equal. That is the magic. That is why it is called magic. That magically this arranges the numbers which have the sum equal to. So you can add one row, 8, 1 and 6. This is equal to 15. If you add one column, 8, 3 and 4, this is also equal to 15. You can add this diagonal 8, 5, 2. This is also equal to 15. That is what is beauty. So this matrix can be of any size. Big size also can be created. So let me create one big magic matrix. You can explore more matrices and can see that what magic it does. Oh, let me show you that can it be done. See this. This is similar. Nothing is different. Why? Because these are saturating. In fact, you see, although these values are very high, so these are the saturating. So if I have 0 values similar to 1, we can create 0 values also. So if I save A equal to zeros 100 by 100. So we can have 0 matrix also. And if I write command im show A, it will show black. See, now 0 is showing black values, and if I store ones, I have already shown you that once the image of ones is showing white, completely white. Where is the image? This is the image. So if we have all values ones, it is showing white image. A have all values 0, it is showing black image. Okay. Do you know concatenation? Concatenation of matrices. If I have matrix A of 3 cross 3, suppose I have matrix A of 1, 2, 3, 4, and X, let us take, and Y equal to 1, 2, 3, 4, and then I want Z equal to 1, 2, 3, 4, and 1, 2, 3, 4. This is called concatenation. So concatenation is possible. For this is horizontal concatenation. Okay, so how it can be done? Can anyone tell me? If I have X equal to this, I can store it like that I have told already, and Y equal to this, I want Z. This, then what kind of code I have to write? Z equal to Z equal to what kind of code I have to write? I will tell. I will there X comma X colon Y. No, Ankul Kumar, it's not correct. You have to give complete. First of all, we have to have one square bracket, then X, then space, then Y. Otherwise, you can use concat command. You are right, Supriya madam. Yes. So you have to put yes, Padmalata madam. We have to put it into the square bracket. Okay, got it. So similar to this, I have A and B. A is also 100 cross 100 size. B is also 100 cross 100 size. I can use a command like this: C equal to square bracket A space B, square bracket close. It will do the concatenation. So C is now concatenated. Whether concatenated or not, I can see it using I am so command C. I am so C. C concatenation done. Concatenation done. You are able to see that the black which was stored into A and then white which was stored into B, both are together now. Which command I have used? I will just go to the history. I have just used this one: C equal to A space B. Then images concatenate. Okay, so similar to this horizontal concatenation, if I have to do vertical concatenation, what I have to do, if I have the problem little different, x is equal to 1, 2, 3, 4 and y equal to 5, 6, 7, 8 and I want z equal to 1, 2, 3, 4, 5, 6, 7, 8. This is vertical concatenation. How to do vertical concatenation? How to do? You know matrix. Many of us know matrix. So someone will help me. Someone will help me how to do this. What command should I write? Those who are new, they should learn. Those who already know, who have gone through these matrix, they will know that what should I write. I have to write a square bracket if necessary and then x semicolon. You are right, Padmalata madam, x colon y, but this should be inside a square bracket. Okay, very nice. So I will do this also and save it into a new variable d. So d equal to a semicolon. In the previous command there was a space, here is b. Okay, so now this let me see whether these are vertically concatenated or not. So for that I have to use I am so which one, d, because we have created d just now. See here the result. See, this is the result. Okay, we got the vertically concatenated. So by this knowledge, by this understanding, you can now horizontally concatenate, you can vertically concatenate the images. So what you can do, one image that have black and white squares, it's called any answer? Black and white square in complete image, that is called chessboard. So chessboard is can be created just for practice. Just for practice, we can create a chessboard just by concatenating these images horizontally and vertically. Okay, so just you understood how to concatenate, how to connect images horizontally, how to connect images vertically by matrix only. I am not taken from somewhere. I have just generated in MATLAB one matrix of 0, one matrix of 1, and then added them together. Then the black and white images came. I want you from you. This is for your practice. That add these images and create a chessboard. So this is for you. Create a chessboard, and you need to send it. I will create an assignment in the Google Classroom. All of you should upload your code into that. Okay, so you just create a chessboard by applying this concept. Chessboard image should be uploaded in Google Classroom, so that you I will understand. There are many ways, because you have to do this repeated thing. You have to create a white again, then black again, and then white again, then black again, like that. Similarly, below also here this should be black, and this should be then white, like that. So the repetition kind of thing has to be done. So you need to create a black chessboard image and upload in GCR. I'll create question for that. Okay. So you understood that a matrix can also be image, and as images are loaded into the matrix can also be converted to images. Great. And now I will again come back to our image processing. So let me go back to PPT again. So I was here. Then magic matrix we have done. You can upload it. Okay, so in the GCR that have we done. One more exercise is there. Okay, so image SC command. There was one question somebody was asking that what is the difference between IMSO and image SC command. See, both are similar. Just for your practice, I have just given here. You can generate a random matrix and you can use image SC command and see that what is how it is different than as compared to the IMSO command. But I generally use IMSO. That is in my practice. Therefore, I have used that. So I had seen this question somewhere some time ago, that what is image SC command? Yes, by Kapil Gupta. That what is used. So both are similar. You can use image SC, but I prefer to use IMSO. That do my task many times, sometimes, most of the time. So that is why. Now this slide shows us what are the types of images. Images are basically of three types mainly. First one is color image. You can see here all colors, green, pink, whatever colors are there. These colors are available. So this is a color image, and this is a grayscale image. This is the image grayscale. This is called grayscale image. This is a black and white image. Okay, so why black and white? Because here only two colors, white and black, are available. Therefore, this is actually a black and white image. This image is grayscale image. This is not black and white. This is grayscale. Means white and black is in a scale starting from 0 to 255. This scale is there. Okay, and this is color image. This is simple. So color image, that too made from red, green and blue. All colors are made by a certain combination of red, green and blue. For example, this is one binary image, black and white image with some edge detection algorithm. So in that I have taken a small area, and if I zoom it, if I see the pixel values in this area, I will get only the values zeros and ones. So 0 will be there or 1 will be there, and no any other value, only 0 and 1. That is why we call it binary image or black and white image. Second kind of image is grayscale image. In grayscale image, values are from 0 to 255. You can see when I have zoomed and reported the matrix from this very small, a very small part is taken and represented as matrix. A very small matrix is taken from that. That is the grayscale. So here you see the maximum value is 255. None of these values. See here, although they have reported, but 255 should be maximum. You can see if you can tell me if there is any value greater than 255. Okay, so this is grayscale image. In color image, there are 3 matrices: one for red, one for green, and one for blue. 3 matrices. RGB. This will have one matrix of 0 and 1. This will have only one matrix for the value 0 to 255. But this will have 3 matrices. Every matrix have values from 0 to 255. This will also have. So these will have shades of red. This will have shades of green. This will have shade of blue. Values will be from 0 to 255 in all 3 matrices. So the knowledge of matrix is important for dealing with the images. Okay. Next is if I have color image and I take a small part of color image, then how my matrix will look like. My matrix will have 3 folds, like pages of a book. That a book books one in a book. First page is one matrix. Then second fold will have second matrix. Third fold will have third matrix, like that. So in the first fold, red, this will be in the first fold, and in the second fold, green, and the third fold, blue will come. So all will have the values from 0 to 255. This will also, and this will also, I have already told this thing. Okay. This is different. This is the indexed type of color image. So the reason why this came, the reason is that how many colors are possible by this image, because how many combinations of these colors will be. See, there can be many combinations of these 3, because we have 0 0 0 0 1, like that. So this will change from 0 to 255. This will also change from 0 to 255. This will also change from 255 0 to 255. Overall combination, total number of combinations will be 255 to the power 3. We will get 255 to the power 3 number of combinations. So if I calculate this, this is the number of colors. Okay. So how many? These are many colors. Okay. So 16 crores like that. So these many number of colors are possible from RGB combination. But people were not satisfied with that, because human interpretation research is going on. They want better and better kind of images. So for that purpose they wanted to increase this number. For that purpose, a new color images are now used. For that is called indexed color image. Indexed color image have 2 things. One is called color map, and second is called indices. So it will carry two matrices, one matrix for indices and another matrix for the color map. Now they have flexibility that they can have this color map of any size. You can increase the size of color map. What this indicate, this matrix indicate, for example, if you have 4, that means that you have to take the index number 4. You can say 1, 2, 3, 4. Then 4th color map will be applied. If number is 6, then this 6 number color map will be applied. So this way they have now the number of colors are infinite, depends on the requirement. But as much large color map is there, that much large indexed color image will be having this. Okay. So this color map have the first column of the color map represent red, second green and third blue. RGB combination also only, but this is now not limited to the values from 0 to 255. This can have fractional values. See here, values are fractional, so there is no limit. Infinite numbers are possible. But in the previous one, there was limitation of 0 to 255. That the values can be between 0 to 255 only. Okay. So when reading this image, you have to read two things. First is matrix and second is map. This kind of images, if you read, so this is Abdul.jpg. This is not actually there are some different images for that purpose. So that is when you read that this will you have to give. And there are some built-in color maps like jet, HSV, hot, cool, spring, summer, autumn, winter, gray, bone. These are the built-in color maps in MATLAB available. You can change the color map also in between. For example, I will load an image and I will show you color map. One image that is predefined in MATLAB. Yeah, I have to close all first and then CLC. Unload FluJet. Then you have to this for showing this we have to use image command. Okay. So this is actually FluJet. So color map can be changed. So if I change color map to jet, and now I will show you the same image. But this is actually shown, but it is in background, so I will just close it and then I will write. See, color map. Let us change to other actually. Suppose I change it to let us change it to hot, to cool, anything. Cool. Let us see now images. Image color is changed. If I change it to hot, now see the color image in this color of image is changed. If I change it to any gray, so color map gray, like that. But these images are some special images. Okay, so where you can change the color maps and just see the image in different colors. So this is for the only for the indexed kind of images. Okay, so this was now let us discuss about the size of image. So if I have an image of binary image of 512 cross 512 and grayscale image of same size, RGB of same size, index of same size, then what will be the requirement of its memory? How much memory they will consume in the storage devices? So one pixel takes 1 byte So if we have 512 cross 512 pixels of binary image, so it will take 512 cross 512 cross 1. It will take 32768 bytes. If we have grayscale image of 512 size, it will also consume same size, because even for the values for 0 to 55 also we can store it into 1 byte, 8 bits. But RGB image will take 3 times data, because there are 3 pixels, so the requirement will be these many 786432 bytes. But index image will be having much more larger, and it depends on the color map. You see, the images are of course larger and depends on the color map. Okay. How many images are supported? Different, many types of, like BMP, GIF, HDF, ICO, JPG, PNG, TIF, all are supported in MATLAB. Data types, mostly images are saved in event 8 type of data types. So, and you know that in the MATLAB, data type is double. So when you are mixing your MATLAB created matrix and image matrix, then there is need of data type conversion. You have to convert your data type into event date, and event date should be converted to double. So mixing, you have to when you are mixing MATLAB created matrix with the loaded matrix of from an image, then that is called then that is called the image. You have to convert it into this event date, the mostly used data type in the images. Similar to the audio info, there is command IMF info. This IMF info command gives the information about the image format, version of the image, modification date, file size, image width, image height, number of bits, and RGB intensity. Let us do it in the MATLAB. So, for example, if I say IMF info Atul_new dot jpg, we'll see it will show you everything. When I modified, if it is modified, then it will not show the capture date. Otherwise, it will tag. It will capture. It will show you capture date also. Okay. So it is modified on this date. File size is this much. Format is JPG. Width, number of pixels in the columns. And height 284, bit depth 24, color is true color. True color means RGB only, and format there is no. Number of samples 3, that means RGB, and coding is Huffman coding, sequential, that is Huffman is in the protocol of JPG, so that will be there. And this Windows photo editor software have been used, added this image, because this is not original image. If this have been original image, it will show the name of camera. Date and time on 6th June 9:37, I had modified this image. Okay, digital camera it is also showing, but it will not show you that data. If I increase the screen size, it may show something. Okay, so this is not showing the camera name, but we can know at least that it is RGB or it is indexed image. Okay. Any question till now?
Yes, sir. There are some questions in chat box.
Yes.
Would you kindly repeat unsigned integer into index by UP Verma, sir?
Unsigned integer into index image is different. We do not use practically and in general. And unsigned integer is practically, or most of the cameras that they provide event date. So I think we'll share this recording so you can see it again. Okay. Any other question?
Okay, sir. There are some more questions. Okay. Yes. Can you demonstrate the edge detection? This is the latest one question. And before that, there is a question by Supriya Nayak.
So it will come in future. This time cannot be demonstrated. It is a filter. When we apply filter to the image, then edges will be detected. So when we do the filtration, means filters, 1D filter and 2D filter, at that time I will show you edge detection. I will definitely show you. Okay. And any other?
There is a question by Supriya Nayak, madam. That can you explain number of channel in every type of image?
Number of channels. See, in images, channels are not there. Channels are there in audio only, but here the data, if it is coming from multiple channels, it will be averaged and it will be only one matrix for binary image, one matrix for grayscale kind of image, three matrix for three channels kind of thing. You can find this three matrix for color image. That is what is the answer for that. Any other question?
Sir,
Yes, so there is. Yes, Kapil.
Sir, event command is used for to convert a number into integer. So if we have a fractional number, then we lost some data when we use event command.
Yes, you will lose some data, definitely.
So how can I save my data?
Because see, if you have any image, already if you have image, you are doing some modifications, then that image will have initially data in integers only, and if you do some modification, then result will also be integers, and if there is a little bit fractions, that will be lost when you save it into the event date kind of image. And that is what that is actually in the property of images. They take origin only integers. So that is a problem of cameras or the encoding system. That is not problem of MATLAB. MATLAB can do fractional analysis. There is no problem. But cameras do not accept. They do not store data in the form of fractions.
No, sir. When I am converting a one-dimensional signal into 2D signal, like image,
yes.
And we get some fractional value.
Yes.
So how can I save this fractional value as an image?
You can save that. You have to convert it into the fractional equivalent values. You can convert into the equivalent values.
Sir, actually, all values are less than 1.
Okay, then if you want to save, ultimately we can save fractional values in binary numbers also, where there is no availability of decimals. What is the process? That you have to just convert into the equivalent representation kind of. So for integer part, you can have separate image. For decimal part, you can have separate image. You will be able to retrieve it when you want. So understanding, you can separate integer part and fractional part. You can save the integer part into one image and fractional part into other image. If you want to save it into the image, that is the way, one way to save your to keep your data. Then when you are getting back, again combine back in them, and you can do your work. That is one way. Okay. Any other question?
Yes, sir. There's a question by.
This is one way to do that work, to save your data, fractional part. Otherwise, it will be lost. Yes, any other?
Yes, sir. There's a question by Ashwini Salunke. In image, how we will crop certain area by matrix?
Yes, I will just show you this thing. Cropping, I will just show you. Cropping part is yet to be covered. I will do. I have just given an idea when I was discussing matrix. So from that idea, you can crop just by taking a sub matrix from the image. Otherwise, I am going to show you. Okay.
Okay, sir. One more thing. Can we convert a black and white photo into colored image in MATLAB?
Can we convert a black and white photo into color? See, yes, this is a good question. In fact, why? Because in color image there are 3 matrices. In black and white there are 1 matrix. So immediately we can understand that there is more data in the color image and less data in black and white. Because in black and white only 1 matrix, and in color image there are 3 matrices. So data is lost. Means you have to generate a data for 3-dimensional matrices. So there are algorithms to convert a grayscale into color image, but color combination you have to give to the MATLAB, that from where MATLAB will take color combination. So if the image is related to some forest area, then you have to give other image of forest, color image of forest area. From that MATLAB can pick the colors and then it will add it to your previous black and white image. Black and white, not black and white, grayscale can be converted. Because in black and white, a lot of information is lost. Okay.
Yes, sir. There is one more question. Please give us some examples of application where we obtain indexed image.
Yes.
By Supriya and Ekman.
Supriya madam, the index images are used in the research purpose, in satellite images, image analysis, and the places where they do not worry about the data space, memory space, and there they use this. High quality images are required, then only. Okay.
I have one question. Could be quite fundamental or it could be quite basic. Actually, you said all the colors are obtained by combining RGB, and
Yes.
we get the metrics. So, do RGB themselves have their own metrics to represent?
See, no, RGB don't have any metrics.
So how does a machine recognize, okay, this is red or this is blue?
That's what I was telling, that R have different metrics, G have different metrics, and B have different metrics. That is what I was telling, that RGB, yes, RGB have matrices. Actually, image.
Sir, can I answer for this?
Yes, you can.
Yes, actually, sir, the primary colors are red, blue, green, sir. By combining these 3 colors, we can produce a color image. So these can be converted into grayscale also. In grayscale,
Yes,
we
yes.
have 0 to 255 pixel value. So here you can make use of this grayscale to store the image. You have to consider 8 bits per pixel for intensity. For color, we have to consider 8 into 3. So 24 bits are used for storing the information.
Okay, madam. The one query is that do they have separate matrices for red, green, and blue? Yes, sir. They have a separate matrix for red, separate for green, separate for blue. How they are saved? I will tell you how.
Yeah, actually, you showed this image, and I thought you have separated that small portion from this whole picture, and then from there you have separated the different colors there. So red part, how much red part is there represented by the red matrix. But in original red, if suppose there is nothing like where you have taken a small fraction of image from a large image, I'm talking about individual or kind of a pure red. So pure red will have its own matrix, and if it is
Yes,
there,
yes.
how does it look
If
like?
suppose
It will have more value, sir. Intensity
yeah,
value of pure red is more than
if
compared to green and
this
blue, but it
yeah,
will also have some value.
yes. Can I add something? Just I would like to tell you, if this area is completely red, suppose some area is completely red, and if I take this for my analysis, then this red will be having all values 255, all
Okay.
values 255,
Mhm.
and these will be 0. This green and blue will be 0. So then it will represent red color only.
Okay. Okay.
And
Now, I think still my question is I don't know whether you understood my question or not. Okay, simple question is that okay, by typing the command on the MATLAB command window, can we see the metrics for the red?
yes, yes. That's what I will show you. I will show you, sir. Just wait. I am understanding what you are in the query. Your query is how can we store 3 matrices into one matrix? So in the MATLAB, the variable A can store one matrix. Okay, so how can this A represent 3 matrices together? That's a question.
No, actually, see, question was if something is there by which the machine recognizes that okay, this is a red color. So, what is that particular
This
matrix?
number, so these numbers of this matrices, if the number is 255 for red, and
Okay.
for green, second matrix the same index value, we suppose this is third, then this suppose this is 0, and for the same index, same point, suppose this is 0, then it will understand that this is a red color. This point and this pixel, then this pixel will have red color. And if this pixel have value 0 here, 255 here, and 0 here, it will have green color.
Okay. So when we talk about the color, then we have to consider these three pages together.
Together, yes, yes.
Okay.
We have
Okay.
to consider these 3 pages together,
Okay.
or it
Thank
will
you.
be
That
stored
was my
together
question.
only in MATLAB.
Okay. Then that
When
makes
you
sense. Thank you.
take any image into MATLAB, it will store these 3 pages together. I will show you.
Okay.
I will show.
Okay. Thank you. That makes sense. Thank you.
Okay, I think I understood that. Fine. Now I'll show you here.
Sir, I will give you a link, sir, so that you learn so many things what you have asked related to this, sir. I will give you the link. I have video for that.
Just I'm reading one image. Suppose this image, simple one image that I already see here. There are this about this. Let us see about this workspace. What is coming? This is 446 number of rows and 351 columns and 3 folds of it. This last 3 is representing that there are 3 folds of 446 number of rows and 351 columns. So these are 3 folded. The first fold will represent R, second G, and third B.
So just by looking here in the workspace, we can tell whether the image is color or black and white.
Yes, yes,
Okay,
we can
right?
tell.
Yeah.
We
So,
can tell definitely, and we can separate these matrices also because by the using the third dimension. Suppose I want to see the red color matrix of this A, then what I have to write R equal to A, all rows. How can y colon all rows, all columns, and then a first page of that.
yes.
Then it will save. But we cannot see colors. Colors will come only when these 3 are together.
Okay.
We have separated red part.
The way you showed 0 matrix and 1 matrix in a black and white form, we cannot just see the show image red, then it will not show red. Or yeah,
No,
can you do
let me show you how
yes.
it will look. Let
Yes.
me show you. I am show R, then it will show a grayscale image. Actually,
Okay.
why? Because this is a matrix, only single matrix. This is showing the
Okay,
red
got
part
you.
of that.
Okay. Thank you. Thank you.
Okay, so we can separate also. No, all the values also can be seen.
Yeah, this was my question actually. So thank you so much. Thanks.
Yeah, all the values you can see, or 0 to 255 values are there.
Okay, sir. Sir, there is, I think, a last question we
Okay.
can discuss here in this session, that how many possible parameters are permissible in terms of color indexes? It's by UP Verma, sir. I think it will be last
Sir, how many
possible parameters are permissible.
possible parameters are permissible in terms of color index? See, in the color index type of images, there is no limit. As much in color map index your machine permits, you can go to that much. So there is no limit in the color map. Color map you have to make while. So again, I have already told that this is not too much of our work, and our images, the parameters are from 0 to 255. Whatever images we store, you can try from your camera, from your mobile. That image will have values from 0 to 255 only. So that is the limit of images, color images, from 0 to 255. If you are thinking of index images, there is no limit. Indexed images are different, and their sensors and cameras are also different. Okay.
Okay, sir. I think there is no question in chat box more. So,
Okay. If
queries,
you all, you can continue. What do you say? Okay, so we'll do little more. We'll discuss little more. I'll do. So there are basic commands.
Just 10 minutes left. We can continue in next session also, sir.
Okay, so then we can continue in next session. So just you can understand these are some basic commands of images to read, to bring them into the MATLAB. This is to show them. This is to save some data from MATLAB, and this is to convert to grayscale. This is for convert to black and white. This is to convert to histogram, and this is some special toolbox. So this need a discussion, a separate discussion. So I will continue in the next class. Okay. I think it's sufficient for today, and we can stop here. We'll continue in the next class.
Yes, sir. It's okay for today.
You can
Thanks.
do some
Thanks, sir.
practice if you want. So people can do some practices if they want.
Okay.
If you have query, yes, any query from previous class?
Yes, if you have any queries, you can write here in chat box. Otherwise, we will end up the session here. This is quite sufficient for today from our side. We will continue with some new topics, some interesting tools, some interesting commands, useful commands in MATLAB regarding related to what do we say, image processing in the next session. So,
Okay. Okay, so I'm just.
I think we can end up the session, sir.
Yes, yes.
Okay. Thanks to all of you. Thanks, dear participants. Thank you, sir, for such a creative session. I think we are getting some good knowledge. Yes, UP Verma sir is asking something. Please unmute, sir, your mic. Your mic is off, sir.
Suppose I have to collect, I have got the number of parameters, say for instance, latitude is there, longitude is there, there is the time is there, and then so many parameters are there. Then for one parameters, how to metricize, say values are given in thousand or in decimal also. So how will they will be coded for color? One parameter. Hello. Hello.
Yes. Tushar, are you there?
Yes, sir. I have got number of parameters like time is there. One. Say next is some values of total electron content is there. Then there is the latitude location is there. Longitude location is there, and there is the value of magnetic component values is there. They all have been given on the data sheet, and then for the maximum value I have got suppose in thousand or in lakhs. So from starting from decimal to thousand for one parameter, how to give them the or assign them the color index for matricize how to give assign them the matrix value.
Okay, actually, in images, the maximum value will be 255.
Yes.
So I don't think that it can show that. It may show some error, but I think we can try that once.
Okay, sir.
It will give you a practical result because that is
Fine.
a practical question.
Yes, sir. Thank you,
Okay,
sir.
so I'm noting down the question, and I think we can do some work on that.
Okay, sir. Okay, sir.
Okay, sir.
Okay.
Okay.
Thank you. Thank you.
So thanks to all of you.
Thank you, sir.
We will share the handout as well as the practice sheet for today, and the last session we will share that in GCR. Please download after this class or in tonight. Okay.
Okay.
So thanks to all of you once again for good participation.
Okay. Thank you, sir.